Now we discuss our last topic, which is separate chaining. Right? This particular algorithm comes under the closed addressing or direct chaining. Now to understand separate chaining, it's very easy method, right? So what it is a kind of a chain of linked list. So we are considering 0, 1, dot, dot, m1 minus 1, and all the locations are initialized with null. Right? This is the first step. And each and individual locations are not directly storing the key values. They are basically a pointer variables, or you can say that each location are capable of holding an address of a node. That means since we are dealing with chain of nodes, or since we are dealing with chain of nodes, so obviously if I take a k1 key value and if I use a hash function, whatever hash function you want to use, and if I get the value as 0, then what will happen? A node is created and the address of the node is stored in the 0th index. This 0th index will hold the address of the first node of the entire chain, right? So if I take another value, key value k2, and I apply the hash function, and if I get a 0 again, then there is no such concept of collision over here. What we do is that we simply, sorry, this is K1. So what we do is that we simply insert a node at the end of the current chain, right? So what happens? So if it is 0, we check whether it's null or not. So we already have some nodes present in this particular hash. So if it is 0, then we check whether 0 is null or not. So it is not null. That means we already have some nodes present under the hash index 0. So what we do is that we create a new node and we place K2 over here, and the chain continues. So it's just inserting a node at the end. That's what it is. There's no new concept. If I take another K3 and apply H to H over here, and if I get say 1, then a new node will be created and K3 will be inserted, and this will have the address of the first node in this entire chain. So this is what a separate chaining is. Very simple. So we will try it with the help of an example. So the nodes, the key values are given to you, and we consider that the value of m, is 7. So there are a total of 7 different locations. So what we do is we draw an array where there are 7 locations: 0, 1, 2, 3, 4, 5, 6. So all are initialized to null. We will start with 7. I am following the division hash function over here. So what we do is that, so 7 means h of 7 will be equals to 7 mod 7. Okay. So 7 mod 7 is 0. So first node is created with 7, right? So now we move on to 21. So 21 mod 7 is again 0. So there is no concept of collision like what we have dealt in other methods, right? So now we move on to 18. So when we move on to 18, so 18 mod 7 is 4, right? 7 to 14, it's 4. So what we do is we create a node and we write 18 over here. Now we move on to 36. So it's basically 1. Right? Now we move on to 52. So 52 means it's 3. So third location means 52. Now we move on to 61. So 61 means it's 5. So 5 means it's 61, right? So now we move on to 11. So it's 4. 4, that means we have to insert a node at the end of this linked list, which is 11. Now we move on to 23. So 23 mod 7 is 2. 21. So 2 means we have to insert a node with value 2. So in this way, we can insert the key values in a array of pointers, which are basically pointers to nodes, right? So this does not have a concept of collision. If for two different key values we have a same hash value, then the only thing we do is that we create a new node and insert it at the end of the present chain of linked list. That's it.